Hello, hello. Let everything get going here. How's everyone doing? Probably don't actually have that many people yet. We'll hang out. I'll save my hellos. Oh, I gotta pop this out. Pause. Let me tell you, it feels like Friday. Feels like Friday to me. I don't know why. This morning I was like super alert, or like, you know, could focus, and now I'm just like, it's like Friday. Good morning, unexpected maker. Hello, DCD. Oh, I'm sleepy. Hello, Luis. Did I set that okay? Welcome to a deep dive. I don't take myself too seriously. Mark says, today has been a very Friday feeling Friday. Yep, I get that. I feel like, hi Beata. I feel like up until Wednesday, like Wednesday to Wednesday, I was like super focused. And then I got up super early, well, not super early, but earlier than normal to do the SiLabs presentation yesterday, to be a part of that. And I slept poorly because I set my alarm for like 5 a.m. or 5:30 a.m. And when it's that early, my body, like, I don't sleep as well because I'm worried about getting up. So I like got up even earlier and then I was here and my partner texted me like, hey, the kiddo's got pink eye. So didn't work a whole lot yesterday and I was tired anyway. And then today I've gotten some stuff done and was focused, and now I'm just kind of like feeling the Friday afternoon. DCD says, thanks, great introduction to CircuitPython yesterday. Good, I'm glad it went okay. Hey, Timonsku. It would be a lot earlier if I didn't have a 1-year-old. Like, he usually gets us up between 6:30 and 7:30, 6:30 and 7 anyway, so it wasn't too bad. It could have been worse when I used to sleep until 8, but yeah. Johnny says, I'm back coding again in C++. It was painful to switch from Python, all those missing semicolons at compile time. Right. Hello, David. All right, I think I've said my hellos, and my windows are approximately going to be off screen. The new Stripe UI looks worse when I make it into a tiny box, because we use, not Stripe, Slack. The Slack UI is worse, smaller now. I usually have it open just in case I get pinged internally. Okay, so let's do our intro. Hello, everyone. My name is Scott. I work on CircuitPython for Adafruit. If you don't know what those things are, CircuitPython is a version of Python designed for little tiny, inexpensive computers called microcontrollers. Underneath this metal spot here is a little chip, and that runs CircuitPython all on its own. It's got RAM and a CPU and all that. So CircuitPython runs on those things. And Adafruit is an open source hardware and software company based out in New York City. I work remotely for them in Seattle. So that's the deal. Yeah, Timon says, we actually might have very similar sleep cycles then, haha. I'm currently fairly close to Pacific Standard Time. Yeah, see, I'm pretty convinced that Lady Ada is also pretty much on Pacific Time, so it works out for me. For sure. I might start using semicolons when I do Python going forwards. You can. It just like, it'll get stripped out by your linter or whatever, or your formatter. Hello, Space Pope. All right, so bear with me. I'm a little out of it today. What I thought I'd talk about is, one, we hit a really cool milestone this week in collaboration between largely between Dan and I. We have a CircuitPython 9 Alpha 2 released. So this is actually the first Alpha to be released. Yeah, Timon says, I'm on Pacific time, but I'm in Germany. Yeah, I mean, Lamore is in New York City, and I'm pretty sure she's on the Pacific schedule too. It works really well for me. When people are like, oh, you work for people on the East Coast, you must have to get up early. And I'm like, no, I don't. The reason I have to get up early is because I have a 1-year-old. Yeah, so big turning point for CircuitPython. We hit the first alpha on 9. That means that we've updated all of to the latest released version of MicroPython. If you don't know, MicroPython is kind of what powers the Python. Largely provides us the Python core. And so by updating that, we get some new features, and I'm actually going to look at one of those features later today, or later in the stream here. Timon says, I love working for the US for that you get to sleep in and stay up late. Yeah, so CircuitPython 9 Alpha 2 is out. That's the first alpha. It has MicroPython 121 in it, and we were waiting to do this alpha release until we had a version of, we were on a version of MicroPython that didn't have any, we didn't plan to change the MPY version format at all. So hopefully the MPY version is set for CircuitPython 9. I just made a PR and Dan released it to build bundles with 9.x. So keep an eye out for that. We've had a number of folks saying like, hey, I'm trying 9, but my MPY files don't work. So we've been telling them use Py files, which you still can do. But we'll have, sometime overnight, we'll have a 9x bundle build and hopefully succeed. Just noticed no closed captions in live YouTube. It is enabled, I think. It should be enabled. I think I have the same settings. That's not what I want. There we go. Closed captions. Oh yeah, it does say it's disabled, and I'm not sure why, and I can't change it. Sorry. I think I'd have to start the stream again to turn them on. I should have checked that. I'm sorry I didn't, but these are settings that get shared with the other like Adafruit folks, so sorry. I could like end the stream, but I can't. Yeah, I don't want to end the stream. Sorry folks. Sorry that we don't have, and the video doesn't need to be playing. Sorry we don't have closed captions today. I guess I should type that out. I don't know how they got turned off. They're usually just left on. Hey, C. Grover. Do folks have any questions for me? That might be a way to get my brain back if I'm answering questions. I showed off on show and tell the warning stuff that I did. So there is now a warnings module in CircuitPython, and it's used for the display I/O stuff. So if I plug in this Feather S3 that I had the demo on, and let's go to the desktop. Here, we do to dev serial. So if I do import display IO and then display IO dot display, it will give me a warning. David asks, how much interaction / support did SiLabs need for their CircuitPython port? Not a lot, really. they did a really nice job. They had some email contact with Limor. And Limor, they want to do more with Adafruit, and Limor kind of replied like, hey, like, you want to make it more likely that we do stuff with you? Well, it would be great if your chips supported CircuitPython. And they kind of went off for, I guess, a few months, and then came back to Limor and said, hey, we've implemented CircuitPython. And they made a PR, and I reviewed it and merged it, and that was that. They didn't take a lot of hand-holding through it, anything, or at all. Not much at all. And then they asked us to participate in this tech talk, and I thought, it's really cool that they added CircuitPython support for the chips. Like, I'd be happy to do that. So I am, for sure. Unexpected Maker says, I went to update CircuitPython repo before fixing that QIO stuff for my boards and did a fetch all instead of fetch. Now I'm getting every bloody submodule for every port for everything ever. OMG. The fetch all submodules should still not get you all the Git history, but yeah, there's a lot of stuff. Timon says, not a question, but a random thing that just came to mind. There was a pretty bad bug for the S3 in earlier IDF 5.1 release. I think that was paired with one of the latest MPY versions had the buggy sub-release. So maybe something to keep an eye out if you're working against the latest patch release. I think that I got a warning. I think Jim warned me that there's like some BLE bug, but we don't really we have like half-baked support for BLE on espressif. So it's not something that I'm like too concerned about. Certainly there's going to be bugs and people are finding them, and that's great. Hopefully when I get my brain back next week, I'll pick some of those up and start hammering them out. But yeah, brain's not here today, or at least not anymore. So the thing that I was working on or trying to work on is, well, I did the bundle release stuff. So I was really excited this morning about the alpha going out. That Dan did all the work for that. And we've had these support issues around the bundle, so I wanted to get that set up. And so that was the main thing we got going this morning. And then the other thing I've been working on was the next piece of work I wanted to do after 121, MicroPython 121 was merged, was the switching CircuitPython to doing the automatic heap growth. So in MicroPython 121 for the Unix, or not even the Unix, but just the espressif build, they now have this, they start with a smaller heap and then they go back to the IDF to get larger and larger chunks to expand the MicroPython heap as they need it. And they're only using it in that case because one, it makes it run faster if you're not using all the memory. But two, it means that you can more dynamically share memory between MicroPython and the underlying system. In the IDF's case, like if you're doing a bunch of socket requests, the networking stack under the hood may require like pretty large chunks of memory. And if you are, the way that we do it in CircuitPython is like we basically take all of the external RAM for CircuitPython, and then we have this setting that I'm removing on how much you want to basically give back to the IDF so the IDF can use it. So by doing this auto heap growth thing, it's more of a kind of a race to use it sort of model, which allows you to like better balance the memory use between the internal and external. And the reason that I really wanted to switch over to this is because there are a few cases in CircuitPython where we want to allocate memory but have it live longer than the MicroPython VM. And so that is, by having an outer heap on everything and growing the MicroPython heap as we need it, we can allocate straight to that outer heap and then keep those things around. We just have to manually manage them. The benefit of the MicroPython heap is that it does all of this like garbage collection for you, whereas the outer heap is not. You just have to be really good with your mallocs and frees. So I had originally done some work on this a few weeks ago, but I didn't have the heap growth stuff. So I ripped out, we had this mechanic in 8 where you could do an allocation, and we called it like the supervisor memory allocation stuff. And if the VM was running, it would allocate it in the VM. And then there was a process where when you were tearing down the VM's heap, you would basically copy the memory that you wanted to live past the VM to a new spot and update the pointer. So there was like some indirection there. But moving memory is really hard to do because like basically no code in embedded worlds expects you to be able to like update pointers that they're using. So like the RGB matrix was one case where it was just like leading to some issues where here's the issue. Yeah, so maybe Timana's giving me an issue where we should update the IDF again. I don't know exactly what version of IDF 5.1 we're on. FPU registers are not properly switched. At a context switch. IDF 5.1 RC. This is found in June. We're using 5.1.1, I think. Yeah, I think we've got this. Oh yeah. This fix is part of the 5.1.1 release. So you can see the version that we're using by, I go to Adafruit, CircuitPython. If you do ports, espressif, esp-idf, and then this, like we carry a few changes on top. But you can see that like the latest commit we have on the IDF is like September. So it's pretty up to date. I don't think we have that bug still. Funky math bugs if not fixed. I haven't seen it. Okay, so I have this branch, and one thing we can check to see is if the CI is run. I call it switch to split heap. So this, in the case of the espressif port, what we'll do is we'll use the IDF to do the allocations under the hood for us, and then by default for all of the other ports we use the thing that the IDF uses actually, which is called tlsf. There's a library that actually espressif has forked and maintains for use in the IDF that I'm just using directly on the other ports. And that does a basic heap management for us. So I switched everything over to that. You know, I didn't switch the Unix port, and I wonder if I should. The Unix port as MicroPython uses it, does use split heaps, but it uses a fixed number, I think. And that's probably fine. Yeah, so I'm kind of at this point where I think it's building, or at least this red X says it's not building. Pre-commit failed, but boards are going. So some boards still failed, so we could take a look at those. I've been in this world with the MicroPython updates where building, once I get building fixed, then I get tests running, and then I assume it works. You can tell me where it doesn't work. So I'm I'm at this crossroads of generally it builds. So how do I, generally it builds. So what do I need to do to actually test it to make sure that it still works? Like the heap growing stuff works. And I think I just want to smoke test it there is going to be some weird cases that we're just going to have to deal with. Syntax warning. Oh, this is a code size issue. Overflowed by 440 bytes. Great. Those ones aren't fun to fix. Like, okay, how do I magically find 440 bytes? All right, well, we'll let this run. Raspberry Pi 0 failed. Oh, the cast alignment thing. So annoying. So the TLSF library is what we're using to manage the outer heap that lives for the lifetime of CircuitPython. Not the VM, but like the actual run. LED glasses. Oh yeah, I should fix that. I renamed it. Okay, so there's a few board fixes I need to do. It's probably best for me to just wait and let this run, and then I'll see what fails. It doesn't make a lot of sense for me to do it now. So let's just try it. So I have this board here that's a Feather S3 TFT, and I don't know what the code.py on here is. But let's disconnect, and we'll just build it with the split heap and see if it works still. And in fact, you can see there that like the last build I did didn't work, but I thought I fixed it. Had an RGB matrix issue. So we'll try it. I have the RGB matrix still sitting here on my desk, so that is one I want to try too. Because the fix that I put in that was released in 8.2.8, it's kind of like not that great. So this change here switches the RGB matrix to using that outer heap for the stuff that it needs to. So I'm curious. Okay, but we have this cast alignment issue that the TLSF stuff is introducing, which it shouldn't need. I guess we're compiling it regardless. We're not actually using the TLSF stuff. We're going to use the esp-idf version of it anyway. So I wonder if I should change it so that you actually switch it on. Like this is where it's being pulled in. Either that or I just exempt it from the check and call it good. That's what I think I might do. It just won't get, oh, you know, I wonder if we'll get a link error actually. We might get a link error. Let's just try this and see. Because this is like this TLSF code is literally what the code that is used by the IDF to manage its own memory. And in fact, that's how I found it. Is like I had talked to them and they were like, we're switching to this in IDF5 because it's like designed. It's a memory allocation system designed for like embedded systems. Like I think the main selling point is that it's a fixed amount of time to do an allocation. And then it's also a good fit algorithm, so it like does a better job at not fragmenting. It's not immune to fragmentation, but it doesn't. So in CircuitPython, like we'll just start from the beginning, and the first place something fits, we'll put it. But the TLSF stuff tries to like kind of like it won't necessarily start at the start. It does a better job at finding like holes in the heap that things can fit in, or that are good fits for that. I don't know how it does it. I just use the library. PM allocate is redefined. This looks like a protomater problem. Why is that? Source. Okay. We're gonna have to fix this for testing the RGB matrix anyway. Protomater. Source arch S3. How did this work before? CircuitPython. It's only on the S3 that they do that. Not PSRAM for the frame buffer. Let's see what we currently do in CircuitPython. RGB matrix allocator. Not PSRAM. I thought you could. I don't think that. I feel like this would still conflict with this, but let's see if we can't do something similar. That is the tricky part of, like, I thought the S3 could DMA from PSRAM. I don't know why it can't. But maybe protomater cares more? I don't know the full history of this. Is that gonna make my compilation issue go away? Chat is quiet. I'm quiet too. May not go the whole 2 hours. We'll see. Maybe I'll take a nap. Hey, well that worked. Not sure why, but let's try it. I have the UF2 bootloader on here, so I'm just loading with that. Oh no! Come back! Like all my panels, my KDE panels disappeared when I did that. I don't know why. They're back though. Like my whole desktop went away. Well, like the desktop background went away and stuff. You probably saw that. All right, we're copied. And it doesn't boot. It looks like it's very unhappy. Well, caffeine naps are great, by the way. You know, maybe I should have had more caffeine today. I did have some yesterday. Okay, so I don't know if you can see this, but it's like flashing on and restarting and flashing on and restarting. So what I like to do when I'm in this situation is on espressif, I just do printf debugging. So I've got this, well, this is a mini. I've got these nice labels on my boards now. Come on. Product showcase, turn on. I labeled it, and this says N8, which means it doesn't have external RAM, which is what I'm actually interested in. So I gotta unhook and get another board. I don't think I have. So I really like espressif's new dev kits, like this one, but this one doesn't have external PSRAM, which I'd like to try with. But their dev kits are great because the new ones have dual USB. One is the native USB and one is the UART. And so it's great because you put CircuitPython on one USB and you get the debug UART on the other. And then you can figure out what's going on. So I'm going to go grab one of those in my nice box setup. S3. I had more. Here it is. Oh, I bent a pin. RAM. Desire to get a label maker intensifies. Yes, for sure. I got this label maker from Goodwill and then promptly spent like this more money on different size tape for it. It's fine. It's worked out. Okay, so this is 2 micro USBs, which I think I have over here. Here's one. And here's 2. So now this is a 32R8. Ooh. So we're gonna make board equals espressif dev kit 32R8 debug flash, and I will boot it. And I also like with this, you can do kind of a dual TO while you're compiling thing. So split here and then split here. Now here we'll do TO dev serial. Is that right? Yeah. By ID USB. JTAG unit, but we should see the uart too. Not seeing the uart. Why is that? I hope I didn't crash like udev. Did I break it? Is my USB cable bad? I should be able to see like a SiLabs. I should be able to see like a DMA from PSRAM is only supported for some peripherals. That would do it. I'm not sure how protomater works on the S3, so I don't know what peripheral is waiting for. I don't know why I don't see a SiLabs thing. Video problems. See, so like the CP2102, I bet, you know, I wonder if I screwed up my, like there's a thing that creates those devices. New device, but it doesn't tell me like the TTY ACM sort of thing. Okay, this is a stupid error because I didn't clean first. Anything supported by the GDMA controller. So I'm not implemented yet. Well, I don't know. I don't know why this Silicon Labs thing, and usually I would restart my computer, which I can't do because I'm streaming from my computer. I wonder if, I have this other one here. I wonder if this other one will show up. This is the one that's like separate. I bet it won't, but we can give it a try. I like hung udev. Maybe that's what I gotta do, is I gotta poke udev. So, is it the same one or a different one? I can't tell. Oh, poor. Let's unplug this. I turn this. My hover cam is just like blinking on and off. That's just probably what all these messages are about. Disconnects. I put USB through its paces, I'll tell you that. Okay, so the kernel saw it. But again, we're not seeing it in dev serial. TTY. ACM 1 and 2, but that's probably the Inky frame and the USB to serial JTAG unit. So udev is not happy, which I think we can see by doing journal control. Like that's probably the thing, like I lost my whole panel. Plasma. I don't know. Did it flash? Oh, I didn't add flash there. La 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 la. Yeah, the API I have for doing, like, I add this port malloc, port free. It doesn't allow the like different heap capabilities that like the IDF does, which is why it might be okay for protomater to go around it. if it needs more capabilities than the generic like MicroPython stuff. But I think generally, like when buffers are allocated through MicroPython, we assume that we can DMA them. Maybe not. All right, well that, I'm kind of up a creek. The way I was going to debug it is not working. If I plug in that side, I just don't get my, like this dev serial by ID is not updating for SiLabs. If I do it here, we do get the USB JTAG serial debug unit. But it should have gone to CircuitPython. I guess what we could do is we could, let's imagine that this error might be cross-port error that I did. So I've got an NRF feather here, and let's try with the NRF and see if the NRF works. Can't really merge it in if it doesn't work. Feather NRF. So let's see if we can't get CircuitPython split heap running on the NRF. We're gonna have to figure out how to optimize the memory next week. I'm gonna leave that to future self. Future me can worry about it. All right, that was nice and quick. Let's just, no. You know what, I think I might just Jlink it. That's what I was doing with this board last time. Okay. Reload debug. So I've got GDB talking through a Jlink to this feather, and now I'll set a breakpoint in the reset into safe mode thing, and then just run it and see what happens. It's got USB connected, so if it does work, it will come up on USB. Break, reset into safe mode and continue. Blue blink. Okay, and then we got a hard fault. Okay. Oh, good. This is code that I haven't tested yet. This would do it. Sweet. So we're loading the NeoPixel library. Let me highlight this. So we're doing an import. We're doing a load, we're parsing, and now we tried to do a malloc of 21 bytes, and we got to the point where we needed to add more heap. And then we are in the add more heap code. We tried to get, okay, what is the largest split that we could do? And we're in this thing that I implemented, which is get the largest free size. And then we crashed. Ooh, basic I working on the Qualia 9 alpha 2. Sweet. Looks good. That's pretty cool. Yeah, the dock clock display stuff is pretty neat. Okay, so why is this not working? So we're crashing in port 75. Let's pull it up. Oh, and Qt must have crashed because Sublime Text is gone. Okay. Supervisor. Shared port. And we're in get largest free and 75. So let's go up to frame 6 info locals. Max size is very large, which I'm not sure why it is. So it should be max size is 0. A pointer to it gets passed into this function that then gets and then pool walker, max size walker, walk pool, block is last. It is weird. Yeah, this is weird. Heap. Walk pool. Block. So this is right. This is right. So what about this am I doing wrong? There's I above me. So I am at a loss because we're not crashing in max size walker, we're crashing outside of it in walk pool. And I'm not sure why that would be, but we can take a look. We can say live tlsf 764. Like this is the code that IDF is using. Offset to block. Walker versus default walker. Any asserts or validation of the heap debug support in TLSF? I mean, this says while block and not block is last block. So block header overhead. Oh, this is the pool here is, I wonder if I'm initializing it wrong or it's taking a pool in, but that is not the same as, I'm passing in the wrong pointer. Because TLSF create with pool, and then I need to like get the first pool and then walk it. Add pool. Remove pool. So I'm doing this create with pool. So the pool location must be this mem, which is the TLSF plus the TLSF size. And then maybe it's going backwards again into that. And then it's getting invalid values. Oh, here you go. tlsf get pool. Let's do that. And then fit size. What does fit size take? This is what type checking is supposed to solve. Okay, that looks right. That's my guess. I don't know why that's not working. But this totally, well, I was going to say this totally could be the problem on espressif, but I don't think that's the case because on the espressif port we have a different implementation of this get the largest size thing. So they're weak in the outer level, and then in here I am using the heap caps stuff. See, like I have this port heap get largest free size thing. So I don't think this is the same issue that we're seeing on espressif. So I'm just gonna have to do that after the stream or next week, depending on how much. Hey, we got a CircuitPy drive. Okay, so let's do a split here. Dev serial by ID USB Adafruit. Okay. 1 + 1 works. Let's try doing a pretty big byte array of maybe like, I don't know, 20 times 1024. So a byte array of 20K. I barely touched this heap growth stuff, so I'm kind of curious. One gotcha is gc.memfree gives different results now. So this says 110. Let's just learn a little bit about this. So in port malloc, let's just do a mp printf, mp plat print, new alloc of this size. I'm curious. Port malloc. Let's do it this way. Let's even do it like this, where we'll print it after the pointer. Lock equals. I mean, it'd be great if it just worked. How nice would that be? And then import free. Okay. I haven't mounted the file system, so I shouldn't need to unmount that to be nice. Yeah, type validation would be so nice there. The fact that I could pass in the heap, ugh. There are definitely some people talking about how gc memfree changes with it. It does a mix. I think the way gc memfree now works is that all of the pools that MicroPython has gotten will have free space, so it calculates that and then adds the single largest chunk that's available outside of the MicroPython heap. Because the way gc memfree works now. Huh. Core stuff is so far over my head, it might as well be looking at someone's coding in Greek. I'm excited about memory stuff. I'm hoping it'll make it simpler. This does not look like it's actually running, I think. Yeah. Actually rerun. Okay. I think it's in Pi runtime. Or at least runtime.h will get it. Yeah. Get my brain back a little bit, which is good. The other thing is I've had this long-running goal of redoing the build system for CircuitPython, and I think I've gotten closer than I have previously to knowing how I want to do that. The main thing I want to do is, like, with Make currently, all the boards are built independently of each other, but I'd really like to stop doing that. I'd like to be able to share compilation steps across boards to make it much faster to build all of them. All right, it came back up. Okay, oh, we got a port free call with null. That seems bad. So maybe we should fix that. I don't actually know where these are all coming from. So interesting. There's another port free null. Yeah, we should probably fix that. That looks bad. Like, why are we freeing null? But we are also successfully freeing... Oh, so 1536, I think, is the Pi stack. Is that right? We could print stuff out here too. Or what we could do is we could disconnect USB. I have it on one of those USB cables where I can just flip a switch and it goes away. We have a debugger, turns out. So we can break on port malloc. We can reset and then continue. And the first one, the 1536, is the Pi stack. It is safe to free null on some systems, right? I think so. Like, yeah, generally it's a matter of like whether it checks for you or not. Okay, so Pi stack. The initial, oh yeah, I set the initial heap is 12K. Or maybe it's 11K. Something like that. And then size here. Oh yeah, so this is cool. When we do USB stuff now, it uses this port malloc thing instead of the supervisor memory allocation. So I literally deleted the like supervisor memory stuff and fixed everything else to use port malloc. So that's what this is doing. So this is prepping to do enumeration, configuration descriptor. Although if we look here, I guess we missed it. We missed it here. So let's keep going. So this must be Pi stack, yeah, for boot.py, heap for boot.py. And now we're getting ready to run USB. 528 is another USB thing. Hid stuff. So this is cool because we'll be more flexible. And I was talking with Tack about this a little bit too, of like, we could actually be, we can be a lot more flexible with tiny USB now. So like these allocations we're seeing here won't happen if you like disabled HID or you disable CDC or whatever. But there's actually like big static buffers that take a lot of RAM kind of always, even if USB is not active, or you've turned off parts of USB. So I think this world where we're doing more dynamic memory allocation is actually going to be better for memory use, especially on the CMD21 actually, because CMD has like 5K statically allocated by like the build, and the majority of that is all data structures for tiny USB. What was the reason again that you need 2 independent stacks? The reason that I did that is because if you don't use the Pi stack, the C stack is used for small Python stack frames, but for large ones, it goes to the heap. And because they're like large frames at that point, they're actually hard to allocate on a tight heap. So instead, I switched to doing the Pi stack stuff. So it never, to execute a function call, it'll never go to the heap to do it. So that's why we switched. There's also a stackless mode, which actually always allocates on the heap, and that might be better. I don't know. There's a lot of things to think about of like how allocations on the MicroPython heap lead to fragmentation and things. So it'll be really interesting to just see, like with this heap growth stuff, how well it runs for folks. CircuitPython for a number of major versions has had this like long-lived thing, and we ripped that out before we did the merge, and I think we've decided that we're not going to do that. So long-lived used to say like, for everything that's referenced by this thing you just imported, we're going to move it. And again, like moving causes bugs. Dan just closed some of those because we're not planning on doing that. So there is a world where we could think like memory stuff like that makes my head hurt, so I get it. Yeah, it's really hard to know how well you're doing for memory stuff because like so many people use things in different ways. So I'm really curious to see. So Alpha 2 doesn't have this, but probably Alpha 3 will, and it'll be interesting to see how many people go, my project doesn't work anymore, and we'll figure out why and figure out how to tune this stuff. So we're being more aggressive in adopting the auto heap growth than MicroPython is. So I fully expect us to have to tune it on our side and kind of like let MicroPython know like, hey, we did these things. Like one thing I was thinking about is I was reading let's pull it up. Instead of me just trying to remember, let's actually pull it up. So here's our source. In Pi gc.c. And then if we just look for, oh, maybe it's here. Yeah, so here's MicroPy GC split heap auto. So 120 had split heaps, 121 has auto growing split heaps. So this is the algorithm that it does to figure out like how much it's going to allocate. So at minimum, aim to double the total heap size. So allocate, when you need to grow, you try to allocate as much as you've allocated previously. So you get, if you have like 2 blocks, you sum the size of them and then try to get a 3rd block that size. But if it's too big, the new heap is made exactly large enough for that allocation. If it won't fit in the available free space, add the largest new heap that will. Basically take the remainder of the heap up. And so I think it's going to be really interesting. Like all of their testing on the ESP side probably worked with PSRAM, where you have a lot of room. But like we're going to put it, like this is on the CMD21 with 20K of memory, and so it's going to be really interesting to see like how well it does at the tail end of things. One thing I was thinking is like, oh, if the last allocation, if it can't fit, just basically takes the rest, we probably don't want that, just in case you do something that we want to store, like keep it around with. If defrag is a problem, then would a defrag program like Windows might eventually be a thing? Generally, no, because it's really hard to move. Like, it's basically impossible to move memory once you allocate it. Like, you can copy the data, but the hard part is updating all of the people that think something is there. So you gotta, when you do an allocation, you return a pointer of memory, and then you don't know where that pointer, which is basically a number, gets copied around. And so if you were going to move it, you would have to go to all the places that it's been copied and change it. And basically you don't do that. Like, that's not the expectation. Fragmentation is just generally a property of like the algorithm you use to pick to where things go. So there's a lot of the tuning we'll have is like, how do we exactly grow the MicroPython heap as we need to. So yeah, we'll see. This is aiming to do doubling, but doubling is probably, especially on the small RAMs, not going to really work. Like, you're only going to get 1 or 2 doubles maybe before you hit the case where you don't have anything left. Yeah, so we'll see. This is why it's alpha. Yeah, it'll be interesting, and we can tune it for sure. Okay, so PyStack for code.py, and now the heap, and I should probably make this number. I think I hard coded it. Main 197. I just guessed. I came up with this number when I was just doing the testing. What am I thinking? Brain. Port malloc. So here's the PyStack allocation size. So it has a default value, but then it will check the settings.toml. Timon asks, did you read books on this topic, or is something you learned during your degree? I remember seeing a little bit of heap stuff in my degree, but it's basically not what I'm pulling on. A lot of what I'm pulling on is the investigations I did years ago on the MicroPython heap. And then the TLSF stuff, I really just copied espressif. Like, I had a conversation with Ivan, who works at espressif, and he had mentioned to me that they were switching to this TLSF thing for IDF5. And so when it was like, I need some code that will give me a heap. I need some code that'll give me a heap. It's just like, oh, I'll just use what they found. And, you know, some smart person came up with it. I just adopted it. Yeah, see, so this is just my hard-coded 12K, but I have a feeling what we'll want, maybe what we'll do is similar to the PyStack, where we'll actually like have a default that's configurable by build, and then also allow you to override it in settings.toml. I'm liking settings.toml a lot for stuff like that. Like I could make a thing where you can like do a function called a supervisor that will change it at a later date, and it's just like, nah, let's not bother with that. So this is where the 12 is coming from. I think we should probably just make it a pound define, which might make it harder to do later, but. Okay, so this port malloc is starting to get interesting. So we're now in this like we're trying to make a string copy. We're trying to allocate 21 bytes. And we've run out of memory. So the GC is trying to add 3105. And maybe we just go up one. Info locals. And it's all gone. Come on. The don't move things is just like, I had this moment when I was fixing the RGB matrix problem where I was like, oh, I want to be able to move memory, like we want this. And I was Googling just like, how do people on embedded do moving memory? And it was crickets. Like you couldn't find people that were doing that. And it's like, okay, well that's probably the problem then, is like my desire to move memory is the wrong desire. Like I got to figure something else out instead. And then this heap growth stuff, I kind of knew that was coming, and I was like, oh, well, what if, like, the requirement to be able to move memory was because we like would allocate into the MicroPython managed heap, and then like, and that heap would, at the time, or for a long time, has had to be one continuous chunk of memory. But now that's not, like the split heap stuff allows you to not do that anymore. And then this auto growth stuff is just a bonus where like you only grow as you need it. Yeah, I lost my train of thought. Okay, so we're just doubling again. And we're basically done. So the other thing I want to do while we're off USB, I want to figure out what is freeing null. Just because that's like to me that's what I've heard the term like code smell, like something's wrong if you're freeing null. So I'm just going to say if pointer equals null, this is an NRF and it has an assembly instruction for breakpoint, which is really neat. So you could just reload debug. We'll delete that other breakpoint that we put. Now it's loading the code. It pops up. You can't see it, but it pops up right in the middle of the screen. Because, you know, what's better than running a CLI and having it pop up a window? We're going to do info breakpoints. We're going to delete the port malloc. We don't want that in ASED. But generally, when I'm running a debugger on CircuitPython, I will always have this reset into safe mode breakpoint. And this is what gets called. If you ever have CircuitPython restart and then tell you it's in safe mode, this is how it does it, is by calling this function. So it allows me to catch like the trace that, or the back trace that led to the safe mode happening. Okay, so we deleted that breakpoint. Now we're going to continue. And here we are. We got a port free. And now we're in cleanup after VM 391. So let's take a look at that. And it's in main, line 391. 391. Okay. So cleanup after VM, but then I also added a interesting file system flush. Reset, reset, reset. So it's null because I did it here. But I don't think that's what we want. So this is like the process that, oh, okay. So we do call stop MP here, but we're also freeing it. Is this where we allocate it? What is the corresponding stop and then start? Start. So clean up after shouldn't do it. So this actually should probably go in stop as well. Because start. So start MP does the pi stack allocate here. Then it does the heap. So we'll do the inverse here. We'll do heap and then, and we should be good about setting it to null. There. Okay, so that should be correct. So if we run it again, we won't hit this, that breakpoint that we added. The breakpoint instruction. Any questions? Quiet day. It's Friday. But yeah, I've been thinking a lot about, I really want to redo the build system, which is not a simple thing. But I really want to be able to, like I said, I don't want board builds to be isolated. I want them to be shared. The challenge with that is like whenever we turn modules on and off, we pass them as C flags, and that makes our C flags really different for every board. Yeah, refactor the board's build system. Yeah, it's one of those tasks where it's like, oh, I'll just start it, and it just like goes on. And like one of the challenges is that Q strings are used in basically everywhere. So if you want to share work, you've got to figure out how to make your Q strings kind of like the same in more places. Sharing binaries across builds are also like another level of abstraction, like virtual tables. I found this pants build project, and I think that's the direction I'd go, but it's not. What do you mean that boards are isolated? So if you look in the build directory, like you'll see that this firmware.elf was built in build-feather NRF 52840 express. And under this directory, there's all of the source, like all of the objects for all of the sources are under this directory. So if I build another board, it ends up in a completely different build directory. So like, even if it had all the same settings, it would be in different directories, and we'd do the work again. That's not true from like translation to translation, but like there's so much duplicate work. Like when you make every board, you're compiling like pi/compile.c for all of them, even if like none of the like C flags change the behavior, and like what you get out of it is the same. That what you get out of it is the same as the tricky bit, because Q strings change based on module settings. But they don't really have to. I think there's a way that we could change the way Q strings work so that we number them all globally. Yeah, every board basically builds CircuitPython from scratch. Which the more and more boards we have means the more and more waste we get. Perhaps you'll have to invent a new build system to handle the shared code. I tried. I've started that. I have the domain baremetal.ninja or something. The thing that I was looking at, going on this tangent a little bit, which is probably good. So there's a system called Pants, and I've been kind of like learning a lot about it. They don't actually have C support yet, but they do have a plugin API, and the plugins are written in Python, which is great. So there's a target API and a rules API. And I think the target API is like we would make a target for a CircuitPython board build. And they have this way of like doing defaults as well. Yeah, so Q strings make it hard. And one way we could do that, or one way we could improve that is that we basically factor out the Q string stuff and we try to do it for all things. So find all the Q strings and all the source files and then number them all and try to number them in a way that if you don't have some of them, then you like lose a consecutive chunk. And so you're left with consecutive chunks of Q string numbers. That's the thing that the Q string stuff is what changes it. Being able to like, ideally if you had a hermetic build and they were actually the same, you'd be able to say like, I do 2 board builds, they're in 2 separate directories, but I can say that like this.o and this.o are the same anyway, because they came from the same source. Even if some of the like, the pound defines that it had were different, they didn't actually matter. But because Q strings, Q strings are strings that are interned and they're given a number. So if you have 2 boards, but there's like one Q string that appears in one but not the other, it's going to change the numbering for everything after it, right? Like, so it's hard. Like I've tried to do that analysis of like, if I just build all the boards, how much of this stuff is the same at the end of the day? Yeah, and that's the other thing. So DCD points out, like, how would you catch pound defines that affect the binaries? Yeah, so that's the second challenge, is that we use a lot of command line defines to set behavior. And this is the thing that my brain's still kind of wrestling over. But generally, we know all of the pound defines that we're putting on the command line. So either we require that we actually declare those up front, or we declare those up front so that we only add them to the command line for the files that need it, or yeah, ultimately I think that's what you have to do. You could probably be smart about it, where you like do a run where you provide them all, and Clang has this tool that can tell you all the preprocessor things that happen. So you could like automate the detection that something is used and then like put it out. So this is the thing that I've figured out though. I think I know how to want to do boards. I think what we would do is we would have a build file that had like a CircuitPython build or some target. And then I think we could actually do like keyword args for like display IO. And like you just say display IO equals true or display IO equals false. And then internally the rule would know like, okay, now I need to grab these sources to do that. So yeah, I'm thinking it over. Yeah, the build could be fast, so there would be a way to catch the breaking conditions. Yeah, I think basically you have to get away from this model of like the C flag defines applying to all of the things. Yeah, and there's some optimization that we could do as well of like, for every translation on the SAMD, we do an LTO link, and LTO links are slow, but maybe you could like link everything but the translation strings and do that without LTO, and that would be faster. Feature tags of board features, perhaps. Yeah, that's kind of the idea. That's kind of the idea, yeah. I really do want to do it. The problem is that like the C world and a lot of the stuff we depend on are going into CMake. And everybody I talk to who uses CMake does not like CMake. And so I'm like, and none of, like, even CMake doesn't really solve this problem. Like, if you look at the way CMake is set up for, like the IDF, you just give it a top level flag that says which board you're on, and then you end up with like a CMake directory just for that board, and like that's not, like, that doesn't solve the problem I'm trying to solve. So yeah, I'm still thinking about it. It's not high on my priority list. I was joking with somebody in the pants community earlier that like the day that GitHub starts charging us for the GitHub Actions time that we spend, that's the day it will be a priority to optimizer. That's the day it'll be a priority, like I'm going to be paid to work on this priority to get us our build faster. Every time I open CMake and I see their like own language, I'm just like, oh, this is not what I want. So that's one of the appealing things of Pants, is that like even though the core is written in, there's some core parts that are written in Rust, like all of the plugins are just Python. And Python is one of their main build targets as well. Okay, so we fixed that free. Let's start it back up, and we'll turn our USB on and see where we're at. The pitch of doing CMake is that when like the IDF changes things, then it's kind of like done automatically. I don't really like the world where, like, I grew up in C++, grew up as a like developer at Google. Like after university, I went to Google for like almost 6 years. And they have a mono repo, and like they have this thing where you give the full path to like your header files, so you actually know where you are in the file system. Oh, oops! How did I hit this? Port free run code.py 762. Did I not delete it? 762. Ah. Hey. That could be what espressif is having an issue with. Spin your own scripting language. Yeah, the other problem is that I don't think it needs a scripting language. Like, I also have a background in configuration languages that are not Turing complete, and they are much nicer for certain things, like defining build metadata. So that's one thing I like about the Pants stuff, is they say like, in your build files, like your goal is to just give metadata, like extra information about the things that you're building, which I think is nice. So what I'm thinking is that you would do like, from the top level of CircuitPython, you'd say Pants build ports, espressif, boards, whatever board, and then it would build it. And it'd kind of be like a global, in the same way that we factored out like main, we would factor out completely this this build process. And I think what we would factor out as well is like, we have like a lot of these .mk files, which are make files that we use for configuration. And I think we would probably move to using like pants to do all of the configuration of like, on this board, we want display I/O. Oh, the other cool thing that I like about pants that like really made me interested in it is that it also has a notion of environments. So targets like this, I think, can have options that are like generically command line options. So there are things that like kind of globally apply, but they added the idea of environments. And I forget where it is in here. Oh, no, that's too detailed. Oh, here it is, environments. So it's new, but your targets can say what environment they want. And then an environment can set kind of like globals. So on espressif build, you'd say, I'm building in the espressif environment, and it would define like what the compiler was and all of that, which would be neat, which would be very neat. And they have this like defaults mechanic too, which is cool. So you'd be able to say like we have these we have mp config port.mks. So that would be replaced with build file where we say, here's the defaults. Here's the defaults for this particular port, for example. So yeah, I think this could be the way to go, but there's like some stuff that we have to figure out, how to make it more uniform across boards. I don't know, maybe I'll take a stab at it. Maybe. Let's see if we fix this bug. Let's not get too distracted. Wouldn't be a deep dive if I didn't go off on a tangent. Hey, there we go. So it looks like it's working okay. I think what we should do, we have 30 minutes on the stream still. Let me know if, so this looks nice, like everything is being freed here. Actually, I wonder if the espressif build works now. So let's, I love to do debug prints. In fact, I think I will leave those actually. But what I was going to suggest is let's, I was going to show how I like to delete them, which is using Sublime Merge will show you all the changes you made, and you just hit revert, which is really handy. Where did my, there it is. So now I'm going to try this feather again. And we'll just see if it works. Maybe we fixed the next code configuration thing is what the espressif build was hitting. Don't know what a breakpoint is. Okay, well, this is what I was talking about. Merge. So here we can see changes that are pending. So this is the crash thing we fixed. This is espressif build fix. This is 2. And so you can do discard hunk here, but you can also highlight particular lines and just say discard lines. So I left the prints for now, but we could discard those soon enough as well. But yeah, pants looks pretty neat. The other thing I'm thinking about is like, how could I I don't have to do everything at once. Like, could I do a switch to pants without changing everything? Like, maybe we still build every board, or like C flags still has all the C flags to start. And that's probably the way to go. Like, get it all switched over to pants, even if it's not optimal, and then later you can figure out, like, okay, how do we manage that this thing that can be shared is actually shared? So I guess the problem is that, like, in order to know you can share something, you have to know that the inputs are the same. Whereas, you know, if you compile a file with two different pound defines that don't matter, the inputs are different, and therefore it doesn't think it could share it. So you actually need to figure out how to do that. Which you could auto-detect, and one of the pitches of pants is that it has automatic dependency inference, which I'm trying to figure out how it does it. But I'm wondering if it could have like automatic, like, dependency on command line arguments things. Are the Q strings touching every part of the code base, or is there stuff where you can be sure already that it would be same across builds? Q strings are a lot of places, so that's probably something that you want to do early. Yeah. It's all over like the Py directory and stuff. Anything that's like a keyword, anything that is like a keyword or a reserved word in like Python is going to be a Q string. On the concept of inputs, that's one of the things that CMake is trying to do also. Maybe other tools do that too. What do you mean about what CMake is trying to do? Can you be more specific? But like right now when we add a new module, you have to add all this boilerplate of like adding CircuitPy underscore the module name, blah, blah, blah. But it would be cool if it was like auto-detected by identical inputs for different builds. Right. I think generally all build systems have this problem of like they don't try to share work if the inputs are different. Like, so we would have to figure out how we want to tell it that the inputs are the same. Like, if on the command line we say what the board name is, the input's going to be different for every board. Like you're saying environments. Oh yeah, the environments thing is really cool. The thing, like Meson is another build system and it has integration with CMake. It's also Python-like, or it's implemented in Python. It has environments, but the targets can't say what environment they want to be in, which I think is what I like about this, is like in a particular ports directory or in a boards directory, it can pick what environment it's operating in, and then that applies globals to everything, right? So this feather espressif, say, is build me in the espressif environment, and then that applies to all of the files elsewhere, I hope. I don't have it working yet, but I wonder how I could get this to be a smaller thing. Oh, and I'm looking at my ESP that I loaded, and it is still restarting. So it is not fixed, unfortunately. Yeah. I don't know. I really kind of want to try this pants stuff, but there's no way I can make any progress in 20 minutes. Maybe let's just look at the build. And this is probably all code size. So the problem is that we're bringing in some code with the tlsf stuff. Oh, the Broadcom port has a thing. Oh, this is the alignment thing that we were fixing in espressif, but it still doesn't run. Oh, this one we could fix. That's an easy fix we could do. Simul is probably code size. No, it's not. Dangling pointer. What? Okay, that's weird. All right, well, this one's working well enough. I'll do the espressif later or later. Yeah, I kind of want to try the pants stuff, but I just know it's going to be async. Like, yeah, it would take me a few weeks probably to do that. It is not a small thing, changing the whole build system. And like that includes like redoing how queue strings are done, like queue strings, translation compression would all be great to do separate of boards. That would be nice. Yeah, it's just something to continue to think about. Let's do two easy things. Let's make the one, what is it, the glasses? Espressif we fixed. Adafruit LED glasses. NRF 52840. But yeah, like, pants is the closest thing to what I've found of like being able to do what I want. Share between build targets, yeah. And like that's what CMake hasn't shown me that can be the case. And the reason is because there's so much if this then that stuff in CMake. I was like, I really don't want as much of that. Okay, so this is an easy fix because I changed the capitalization of it. And apparently I didn't change the capitalization everywhere. It's in frame buffer. Display IO in it. Oh, see, this is something maybe we could do in this time. So the other thing that I was hoping, once we have more dynamic memory, I'd like to remove the restriction on how many displays you can have. Now, I wanted to pick my audience's brain on this. So if we don't limit you to one display, do you expect all of the displays, say you have 3, to stay active after your code is done? We're only going to put the serial output on one of the 3. So does it make sense for us to maintain the other 2? Like, we have released displays and it's plural, but maybe it should be singular. I don't want to copy what Zephyr does. I find what they're doing very complicated. Sorry. Like Zephyr is coming from a bunch of people that know Linux, and so it's kconfig for configuration, it's CMake for building, underneath their own tool called West, which is written in Python, and then they also have device tree for configuration. Yeah, I mean, active means, in my book, it means active means that the displayed objects are active still. Now, we don't have a way to get them back. We don't have a way to get them back. Yeah, maybe it is that, like, we can have more than one display outside of the heap, but that's only for like the the boards that have multiple, like we only have one board, the monster mask has 2 displays, right? 1, 2. And it would be cool if we could just have display left, display right or something in board and they just both work. I think that would be neat. But if you instantiate 3 displays in user code, maybe only the first one stays on as the console. So this impacts how where we yeah. If it saved me from maybe having to reinitialize 3 displays when I drop to the REPL if I'm testing there. But that's not really, like right now we don't expose those displays. Like there's no way you can get them back. Like the real reason we keep it around is just so that we can use it to show, like the reason there's release displays, I was thinking about this, like why don't we just disable the display when the code starts? But the reason we have release displays is we're trying to keep it around as long as possible to find any other errors. So maybe there's an error in your code up high before you call release displays, and then you can see it on the display still. But yeah, I think really what it is we just need one display. Like the first display that you allocate in user code is the one that we'll keep around. The other ones will live on the heap and just work. And then go away when the VM is done. But this is a unique case. So for this board, we'll do 2. Like we could just do 2 static allocations. Yeah. You have 2 static allocations, and then. But if you call release displays, you lose those and you never get them back. This is the thing that I want to get rid of, this thing that I have pulled up here. So the way that we currently do is that we have this CircuitPy display limit, and then we have these union structs that basically say like any one of these things can fit in this spot. Right. Yeah, Timon is getting at the fact that like there's no user benefit to having more than one display active. Because assuming that we're only going to show the REPL on one of them. Now the other thing I thought about was what if you, like in this case, what if you could actually put the REPL across the 2? Then you have twice as much space to see the serial output. That would be cool, but that's a much bigger change to display I/O right now. Because right now, like, we assume a group is only in one display. LibreCase say if I have a TFT display and an IS31 display or an LED matrix display. The other thing I was thinking about is like whether de-initting a display prevents it from showing like the last thing. And this is like the e-inks kind of have this problem too. I think what I am getting at is like, it's probably better to just do the first one. But then you also, and it's not even the first display, it's the first display. It's the first display or first display bus. Yeah. Panelized displays. I think in practice that's probably a limited use to have REPL go over several displays. Yeah, and it's a huge change to display I/O. Yeah. The other challenge is like the first display wants to keep around the other stuff. So if we're not moving everything, we have to say the first display bus and the first the user can define where the REPL pops up. So they can actually with root group. So maybe that's, we could allocate all displays and all display buses off the MicroPython heap, but deinit all of them except the one if it has, well, if one of the displays that's initialized has the terminal on it, keep that one. If none of them have the terminal on it, put it on the first one that is not deinit. And yeah. See my, like, I don't want to have to move anything anymore, although that's not going to be true. Because 4wire uses a SPI object, so the SPI object still has to be moved. And I2C display uses an I2C object that also should be moved. This is why I haven't done this part of the code yet. It's because I'm not sure how I want to do it. But the goal is to remove, the goal of changing this would be to remove this display limit. Yeah, there's e-paper as well, or e-ink. How does it work for, say, the monster mask where the board startup initializes both displays? Is there any way to get that back without rewriting all that code in Python? Display equals board.display. So you can have multiple things. Let's see, do we initialize both of them? I'm not even sure we do. But that's not too bad of a problem because you know kind of at build time that you're going to do that and the board knows it. It's more the like, how do we, if you come along and make a 4-wire bus, do we allocate it to the outer heap or the MicroPython heap to start? And I think the answer is we have to allocate anything that might live longer to the VM to the outer heap, and then we clean up everything that we're not going to keep around. I think that's the right call. Like right now it tries to fit in these slots. Well, that's the other problem is that if you're allocating a bunch of stuff that lives outside the heap, how do you manage that memory? Or like, how do you make sure you free it if you actually want to free it? Let's see what the monster mask does. Monster mask board. So 4-wire, and it does this allocate display bus call, and it does an allocate display. Yeah, see, it only starts up the left one. Like that's what this board is, right? The monster mask. Yeah. So it doesn't even create both, which I think it should. Like if we look in pins.c, like it has left and right TFTs. Oh, and it does have, oh, it has display and right display. Right, but it doesn't have a left display, which it should, in my opinion. And it should be kept around. Like if you redo the VM. Yeah, I'm gonna keep chewing on this idea. Any final questions? I know it's been kind of a, my brain is a little bit better than it was at the start, which is good. Keep one for the REPL as long as it, when I restart my program, it hands it all nicely. Yeah, I know, like everything uses release displays, which is like, I wouldn't mind getting rid of release displays, but I also want the error, like the display to live all the way through that. It's tough. Displays are weird. Oh, I missed one. I can go back to doing the simple thing. This is a pretty good example, both in the build stuff and this display stuff, where it's just like, maybe I should just play like an hour of video games and my brain will figure it out. Like, if I stop thinking about it, I'll probably make a decision, probably figure out what I want to do. The pants stuff is tempting simply because I know where I want it to be. Like I know what I want. Like I was talking with Liz about writing CircuitPython drivers, and the first thing I like to do is I like to write the example code before it actually works. Like I feel like I've decided what that is for the build system, right? Like I want in every board's directory to have a build file that is where we configure what modules are active. And then that will determine what it links to and all of this stuff. Yeah. Brain. It is definitely something that I could be like, oh, I just got to get, like the build stuff, once I've made a decision, it's like, oh, I just got to get this out of my brain and just see and just start. You can follow like my GitHub repository. You can find all sorts of like pending branches and stuff that I haven't finished. And like I literally have a domain name for like, I'm going to make my own build system for like bare metal ninja. And it just got really complicated. Yeah, things get complicated. Yeah, example code is the requirements then. Yeah, which is very similar to how Zephyr deals with modules. How is it similar to Zephyr dealing with modules? I don't know a lot about how Zephyr does stuff. I just know that it's like giant and monolithic and makes me unhappy. Anytime I see Python over CMake and like the IDF does this too, is like, I'm like, why aren't you just using Python? You have a conf file for every board overlay in a project. Does it build a separate, if you build two boards, do they share a build directory or not? Yan can pull in the things only you need. Okay. I mean, we kind of do that with the make file already, but it'd be nice if it would be nice if it was like better structured. Like we do this configuration step, which figures out all the source files we need. And then right now we pass all of that down into the compilation stage using defines. But that can get you into a lot of trouble in terms of like, I passed all these defines into this file and most of them were ignored, but the build system doesn't know that they were ignored. So like one thing I was thinking about is like maybe we require, like, instead of doing defines on the command line, we generate header files that have the value. And then those header files get imported so that, like, but then again, like, every board would have a different header file anyway. So I think, I think at some point you have to, like, be like, I actually have to have some metadata about what this needs. The project build directory has to be torn down if you switch boards. Okay, so there's like 2 separate build directories. Yeah. I know kconfig better than I did when I looked at Zephyr last time because of the IDF, but I found some warts of kconfig in the IDF that really make me not want to use it. It's too complicated. You don't need that. Yeah, It's too complicated, and there's some, you can shoot yourself in the foot with it. Every project will hook into kernel stuff with a device tree header changing every time. So they need to do something there. Oh, so it changes the header that impacts a bunch of stuff. Bot Zerker asks if Lady Ada is here. Nope, I work for Adafruit. I'm Scott. I'm not Lady Ada. But I work with Lady Ada. And we're just about done. I'm just talking and thinking. And I've got to fix. I want to fix this build. Simple thing. Case sensitive. I just renamed this. I don't usually camel case the C types. And I ran across it. And I say that, and then RGB matrix is capitalized here. It's okay. It's stunning at first, but it gets really nice after a while. The weirdest bit is how device tree is implemented. Other than that, it's mostly less complicated than Linux does to not seem like a very high bar or low bar, whatever it is. Linux is very complicated. I want simple until I don't, and I want as simple as I possibly can. Extractions for drivers. Yes, that's great, except we already have that in CircuitPython. Like we don't need that part of it. Collect pointers, 354. There we go. Search and replace. That's when I saw this like default thing for pants. I'm like, ooh, I wonder if I could get away with doing that. Like, I recognize that using pound defines is like really complicated. And like, there's this mpconfig.h file that gets like, it gets included into everything. So if you change something there, then you're just getting it. But that's okay. I'm like not trying to save you from changing mpconfig.h. I'm trying to save you from like switching boards. I don't know. We'll have to take a hard look at that stuff. Okay, undefined references. I had this because I didn't do a clean build. No, I need a virtual environment because I'm building in my thing. Kconfig bits are quite minimal. It's like a bunch of this plugin equals Y for project, and that's it. Yeah. The warts I found with kconfig is like I was trying to do dependency analysis for the esp-idf stuff, and then I found the fact that setting some value can force a value somewhere else, and it's not considered a dependency. And that kind of just made me go like, ugh. Like there are a few cases where we need to say like, you really shouldn't have like frame buffer display enabled if you don't have display IO enabled. We do have a little bit of that, but there's simpler ways of dealing with that. Dangling pointer. That's a new one. I don't know why that is. I think it might be because CircuitPy USB is disabled. Anyway, we're after 4 o'clock. I think I will wrap up, even though my brain is a little bit more here than it was at the start. Thank you all for like letting me like bounce these ideas off you. And if you have ideas about all this stuff, and even better, if you want to try implementing it, let me know. You can find me and all these other cool people on our Discord server. adafru.it/discord is the link that will get you there. I'm there during the week, usually, unless the kid has pink eye, and then I'm off and on, which is what happened yesterday. That's why I say that. If you want to support me, you can do so by supporting Adafruit. They're an open source hardware and software company based out of New York City. I am based in Seattle. You can support them by going to adafruit.com, purchasing stuff there. If you have unique shipping constraints, digikey.com can be a better place to buy from for that. And also, they might have things in stock that Adafruit.com does not as well. So feel free to support Adafruit indirectly through our resellers as well. Give CircuitPython 9.0 Alpha 2 a try, and Alpha 3 will hopefully have all this heap memory stuff in it. So give that a shot and let me know where it falls down. BotZerker's got a last minute question. Lady Ada is working on the eyes code for the new 2-inch and 4-inch round screens. Do you know if the software has been made public? I do not. I know the eyes code is done in Arduino, which is a little bit further outside of my knowledge area. Maybe somebody on the stream knows. I would ask on the Discord server. Once it's done, I'm sure it'll be open source, but I don't know the state of it. I actually haven't had a lot of time to watch all of the other Adafruit streams. I think that's it. Thank you in advance to DCD for taking notes. I'm excited that 9.0 has turned this corner, and thanks to Dan for that as well. Yeah, I'll talk to y'all next week. I think I can stream again next week. I'll double check. If you want to be notified, we do have a deep divers role on Discord that I don't ping very often, but like if I inadvertently like think I'm gonna do it and don't do it or stuff like that, I can ping that role to let people know. So ask me on Discord and I'll add you to that role if you like. Anyway, it's weekend. Yes. Have a great weekend, everybody, and I'll see you on the Discord next week and probably streaming next week as well. See you later.